In this video, I'm going to graph the equation y equals 2 sine of 3x minus 1. So a couple of key things here. Of course, the amplitude is going to be positive 2. The midline, this thing has been shifted down 1 unit, so the midline is going to be at y equals negative 1. The phase shift, if you notice, there's nothing added or subtracted to the x here. So the phase shift is not applicable. We could say that there's not one, or we could say it's 0. The period of the function. Remember that the period of a regular sine function, if you're working in degrees, is 360 degrees. If you're working in radians, it's 2 pi radians. This is a function that is going to move 3 times as quickly. So you're either dividing 360 by 3 and the period ends up being 120 degrees, or I prefer to work in radians. Our period is going to be 2 pi over 3 radians, okay? It's going to be basically crunched down. It's going to be a third as wide as it normally is, okay? And by the way, because of that, when I set up my scale here, because it needs to be a third as wide as it was before, my intervals need to be divisible by 3. So you'll notice here, and I also need to be able to divide them in half because I need to have a maximum point and a minimum point that fall in between the intersection points along the axis. So you'll notice here 1, 2, 3, 4, 5, 6. I actually had 6 divisions here, so I can split that up into thirds or halves. You know, again, if you're not working with graph paper, you can set this up probably a little bit more flexibly. But if you're working with graph paper, you'd like to actually be able to use the graph paper the way it's set up. Okay, a couple of things. So I always go back to the original sine function, and to this day I make a little sketch of the sine function. And the sine function crosses the axis at 0, pi, and 2 pi. Okay, so this function, instead of crossing the axis at 0, pi, and 2 pi, it's been compressed by a factor of 3. So you can list those 3 values and just divide them by 3. So it's going to cross the axis at 0, it's going to cross the axis at pi over 3, and 2 pi over 3. And those are the key points I want to have. Now before we do that though, make sure you draw your midline because that's where all the action is going to take place. The midline here is going to be at y equals negative 1. Okay, so I've got that going across here. And again, the midline is not technically part of the graph. It doesn't have to be dotted in. I just tend to put everything on the axis if I don't draw the little dots in. Okay? I usually draw the intersection points along the axis next. There is no phase shift, so we don't have to move these forward or back or anything like that. So it's going to cross at 0, pi over 3, and 2 pi over 3. So I've got it crossing here at 0. And I've got this broken up into 6 parts. So every third tick mark is a pi over 3. So we've got pi over 3, that's 1/3 pi. We have 2/3 pi, 2 pi over 3. 3 pi over 3, 4 pi over 3, or 4/3 pi would be our next tick mark. And then 5 pi over 3, 5/3 pi. And then 6 pi over 3 would be the same thing as 2. 6 over 3 is 2. So you might want to label some of those points. Anyway, this graph is going to hit the axis at 0, pi over 3, and 2 pi over 3. So I've got a point here at 0, pi over 3, and 2 pi over 3. Okay, it's going to be a pretty thin graph. Remember that the maximum and minimum points are going to happen in between these points. So technically you want to take half of a third, a sixth. This would technically be pi over 6. It would be 1/6 pi, 2/6 pi, 2/6 is 1/3, 3/6 pi, which is pi over 2, 4/6 pi, which is 2 pi over 3, 5/6 pi, and so on. I think I've got this pretty well labeled. I'm not going to gum this graph up by putting more in there, but anyway, it's sixths in between. Okay, and anyway, sine function goes up first, so you're going to go up 2 units from the midline. Remember, our amplitude is 2 there. So 1, 2 up, maxes out at 1. And then between the next 2 intersection points, we're going to go down 2. So 1, 2, and that'll go down to negative 3. And then basically at this point, you can draw your curve in. So the curve is going to do this sort of thing. And that pattern will kind of continue. Now, you may want to take your graph out a little bit farther. 1, 2, 1, 2. So it's going to max out at that point, really should max out at that point right there, and then come back around like that, and then this will just kind of continue. So you don't have to show it continuing forever, but you may want to do just a couple of key points there and kind of continue your graph. You definitely want a full cycle, but you'd really like to show that it's going through more than one full cycle. So anyway, that's how you can put together a pretty nice hand-drawn graph of y = 2 sine of 3x minus 1.